Okay, so today we're going to do something similar to what we did last class, where I'm going to ask different functions to come up. And we're going to pretend like we are taking on the role of that function, and we're going to be performing a composition this time rather than an operation like we did last time. So for a composition, these are the ones that are like f of g of x or g of f of x. Remember those from Algebra 2? So in a sense, we're putting one function inside of the other function to try to create a new function. Okay? All right, so I want to start out, and of course Aaron's not here, so that makes things complicated. Who's got, let's see. Who's p of x? Rebecca, you want to take on f of x for the purpose of this example, please?
Wait, so am I both, or?
Nope, you're just this one for right now. There you go, thank you. All right, so would m of x and f of x come to the front, please? You're going to be our first example. M of x and f of x. And would you please start by actually writing up on the board for us what your function is and what your domain and range are. That way we can see it nice and clear.
Oh, I don't know if I got that right, by the way.
Yeah, that should be okay, right? Does that look right, everybody? For an exponential? Oh, it's not quite, because it's the exponential, but then what did the plus 1 do to it? Moved it up 1. So instead of being greater than 0, we're going to end up greater than 1. Yeah. There we go. All right, good. All right, so Taylor, would you write down for me, kind of underneath there where there's space, m parentheses f parentheses x, close both of those. There you go. Now, I want you two to talk about what do you think that function looks like.
Like this going to x. Yeah.
Okay, everybody agree with that? All right, so that's creating the new function. That's the easy part. Usually creating the new function is not that difficult. The hard part is coming up with the correct domain for that new function. Because compositions are one of those things where we have the secret heredity, the unseen heredity. So there's certain characteristics from Rebecca's f function and Taylor's m function that may get handed down to this new m of f function. Okay? And so if we just go by what we get as a result, sometimes it's going to be okay, but there are a lot of times where it may not be. So we have to go through the process of actually checking out what's going to work. What kinds of values can we use for x that is going to work in this new function based on where it came from, based on the f and the m that we started with. Okay? So, you can put the marker down for a second. So my first question is, when I'm asking for m of f of x, if I actually choose a value for x to put into this, which function works on it first, the m function or the f function? The f function, right? Because it's on the inside. So just like with normal order of operations, we do what's inside parentheses first and work our way out. Okay? So if I choose some x value, it's going to be the f function that's going to work on it first, and then the m function will work on that. Okay? So we've got them in the right order. F is first, m is second. Okay? So if f is first, what kind of numbers can you take? What kind of x values can I input to you? Anything, right? Because her domain is all real numbers, right? So she can take anything. So I've got numbers in here. Here's my domain basket. Yes, I know it says Snickers, but just pretend it's domain basket for the moment. And right now I have numbers in here like 0, 3, -1, -2, +2, and 4. Are all of those legal numbers for her? Yes, because she can take anything. Okay? Now, I'm going to actually give you a few of these numbers. And what I want you to do is to take the number I give you, perform your function on it, decide on an answer, and take your marker and write the answer on the back. Okay? And then say to everyone what you think it is as well. Okay? So we're going to start with that one. Perform your function on it. What's your answer going to be? Okay, tell everybody what your answer is.
7.
7. Okay? Now, that's what she gets from it, and now she's going to pass that on to Taylor. So Taylor, first thing you have to do is decide, first of all, can you take that number?
Yes.
Yes. Okay? So now, as best you can, because it's kind of a funky one,
Do I write it on the back of like this one or this? Am I doing this?
you're just doing yours. Yep, you're just doing M.
Okay, so
Oh, I didn't start out very nice on her. Not quite,
is 2 to the 4 32?
but you didn't get 4. She passed what on to you?
7. Oh,
7.
I used 7.
Yeah, so you have to use 7. That's what I meant
Oh,
by I wasn't being very nice to you.
Wait, 1, 2, 3, 4, 5, 6, 129.
Okay, so 129 is the final answer that we get, and you can now put the card in that plastic basket that's over there.
Wait, which one?
Just in there. Okay, so when we're doing a composition, this is our goal. I want to be able to give Rebecca a number. She's going to work on it and get her answer, pass her answer on to Taylor. Taylor's going to work on it, get her answer, and spit out an answer at the end that's going to go in the basket. Okay, that's always our goal with a composition, is to be able to do that all the way through and get an answer put in the basket on the other end. Okay, so you said you could take anything. Try that one. Okay, so what do you get? First of all, what'd you get?
1.
What did I give you?
-2.
Okay, so I gave her a -2. What'd you get from that?
1.
1. Can you take 1?
Yes.
Okay, so work out what you're going to get if you get a 1.
3.
a 3. Make sense? So if she has an answer, that means she can put her ticket into the basket. Okay, let's do one more. I'm going to give you 0 this time. Okay, and you can put it in the basket. So I've given Rebecca a positive, I've given her a negative, I've given her a 0. Everything seems to work. Okay, but if there was a potential for things to break down, where would the breakdown happen? Where could things possibly go terribly wrong?
If like a number couldn't fit into like my equation and wouldn't fit in hers.
Yeah. So it's when Rebecca gets an answer and she goes to hand it off to Taylor. If Taylor can't take that number, then we have a problem. We're not going to be able to get an answer all the way to our other basket. Okay? So it's this handoff right here that we have to be careful about. This is what we have to make sure is going to work. Okay? So if Rebecca is giving Taylor this number, what kinds of numbers would we say? What would we call the numbers that Rebecca is giving to Taylor? So these are the domain, right? These are the input values. So I give a number to Rebecca. She figures out her answer. What's she passing on in general? The output. What do we call the outputs? If this is domain, then that's her range, right? So it's the range of Rebecca that has to work with what? The domain of Taylor, right? Because she's passing it on to Taylor, and Taylor's using that number as an input. Okay? That's always what we have to check, is whether the range of Rebecca is going to work with the domain of Taylor. Well, take a look at what they had. What was the range of Rebecca? Of the f of x?
All real numbers.
All real numbers. What was the domain of Taylor? All real numbers. Is that going to work?
Yes.
Yeah, so we're good. So what does that mean then for the domain of my new function?
It's gonna be
Why?
Because there's like no restrictions in both equations.
Okay.
The domain.
But what I checked from f was the range, and what I checked from the m was the domain. So why does that become the domain of my whole thing? The answer is it doesn't. All real numbers comes from the fact that this basket worked. Whatever was in this basket to start with seems to be working all the way through, and this basket now becomes the domain of the whole chain, of the whole new function. So what was the domain of this basket in the first place? Whose domain was this?
Rebecca's.
Rebecca's. Rebecca was the f. So what's the domain
all
of f?
real numbers.
That's why it's all real numbers. Not because of what we checked here, but because if this works, then whatever Rebecca's domain was in the first place is going to work for everything, and it becomes the domain of the whole thing. So since Rebecca's representing our f function here, the domain of the original f was all real numbers, and so now it becomes the domain of the whole thing because everything worked. Make sense?
Yes.
All right, you guys can sit down, thank you. All right, let's try another one. Let's have K and W come up. You can erase the functions that are up here on the board. K and W. All right, so same thing. If you two would first put your functions up on the board for us with your domain and range. Just write it up there so that we can see it nice and clear. Domain and range too, please. All right, so I want to do k of w of x. So can you just write that on the board for me first, Tommy? What would k of w of x, just that, look like? Okay, and then two of you put your heads together, what's that new function going to actually look like?
Square root of x squared.
Okay, do you agree with them? Ladies, could I have you, everybody shut their lids for right now? Does that look right? Is that what's going to happen when we put w into k? Yeah, because the square root is going to get squared, it's going to cancel out, we're going to get x minus 3. Okay? All right, so who's going to go first? If I decide to input an x value, who's going to work on it first? Tommy. Okay, so switch places because you're going to be our first one. And what kinds of numbers will I be allowed to give Tommy? Any number greater than or equal to 0. So I have a 16. Does that work? I have a -1. Nope, that's got to be thrown away. I got a 4. I got a 1. I got a 0. Yep. Okay. So here's Tommy's domain. Okay, representative numbers of Tommy's domain. All right, let me give you one to start with. Okay, so act on it, do your thing. What are you going to get?
1.
1. Okay, now before you take it, if you're the second function on these, before you take it, make sure you can. Because if you can't take it, I don't want you touching it. So can you take a 1? Yes, okay, so go ahead and do your thing on it. So what do you get?
-2.
-2. All right, go ahead and put it in the plastic basket. We made it all the way through. Good. All right, let's try this one. What'd you get?
4.
A 4? Okay, can you take 4?
Oh, yeah.
Yes? All right, so go ahead and do your thing. What'd you get?
13.
13. Okay, we got all the way through. Good. All right. This time I'm giving you a 0. So what'd you get?
0.
0. Can you take a 0?
Yeah.
Yes. Okay. So work your magic. What'd you get?
-3.
-3. Okay. So we made it all the way through. So does it seem like there's anything in Tommy's domain that's not going to work? Doesn't seem like it. I mean, I got one more number here. It's a 4. But everything else seems to have worked so far. Well, let's double check. What would we have to check here for the handoff?
Range.
The range of
Mine.
Tommy's
Domain.
with the domain of Lucy's. So what's the range of Tommy's?
X is greater than or equal
The range?
to. Y is greater than.
Y is greater than or equal to 0. What's the domain for Lucy? All real numbers. Is that going to work? Is everything that Tommy gives to Lucy going to be okay? Yes. Remember, they don't have to match. They have to work. So they're not a match, but everything that Tommy's going to hand off is okay for Lucy. It's not everything Lucy could take, but it's within what Lucy can take, so that's all good. So what then becomes the domain of the entire k of w function? Say again? Domain? X is greater than or equals 0 because, yeah, it was this basket that was Tommy's domain to start with. And since everything in the basket seems to be working, this becomes the domain of the whole thing. Okay, so go ahead and write down our new domain for our new function.
Just the domain.
Mm-hmm. Yeah, with compositions, we only ever ask for domain because range is too hard to figure out.
It was all
No. What was Tommy's domain to start with? What was in my basket?
Oh, X is greater than.
Okay, so that becomes the domain of the whole thing. Okay, thanks guys. Go ahead and sit down.
Your camera shut off.
Oh,
Oh, it's still on.
I think it's still on. It's
Oh,
just
okay.
my sleep is on. So now you get to look at my pictures from the summer as you're doing this. All right, now, if we didn't know where this came from, if we were just relying on our result, what type of a function is this? X minus 3. What is that? Linear. What is normally the domain of a linear? All real numbers. Is that what we ended up with? No. This is that trait that's getting handed down to this result. Okay, this is the high blood pressure, right? It's the one you can't see, but it is a gene that's getting handed down from one of the functions that created this new function, which is why you have to do this kind of checking and go through this kind of process before you know for sure that the domain you're writing is correct. Because if you just go by what the result looks like, you're going to get tricked a lot of the time because it's going to look like something that it actually is not completely. Just because this looks like a linear doesn't necessarily mean it's an all real numbers domain, because what created that linear was a quadratic and a square root. And a square root has certain genes that are going to get passed on. So you have to go through this process of checking range of the inside, that first function, with the domain of the outside, the second function. You have to check that handoff and see if it's going to work every time. Okay, let's try one more. Q and H, would you guys come up? And same thing, start by writing your individual functions up here on the board for us with your domain and your range. All right, everybody agree? Look good? Domain, range, that all look good? Okay, so I want to do Q of H of X this time. So first write what that looks like in function notation. Q of H of X. Okay, and then you two can decide what that function would actually look like. Okay, can that be simplified? Don't have to solve it, just can you simplify it anymore? Can you just make it a little bit cleaner? Are there any like terms?
Can you do some?
Yeah. Just cleans it up a little bit. There you go. All right, so who should be first on this one? Mackenzie, because she was H, right? Okay, so what kinds of numbers can I have in my basket for Mackenzie? All real numbers. So is a -2 okay? Is a -1 okay? Oh, that's a positive one. Sorry, is a positive 1 okay? Is a 0 okay? Is a 3 okay? Is a 2 okay? Yep, okay, good. All right, here we go. So remember, our goal is to get all the way to the end. I'm going to give it to you. You work your magic. Write your number on the back, say what it is, and then hand it off to Peyton. If it's something you can use, you take it and work your magic and put it in the basket. If you cannot use it, don't take it. Okay? All right, first one I'm going to give Mackenzie is a 2. Okay, what is it?
9.
A 9? All right.
I can take.
You can take that. All right. So work your magic on that. Just say it's log of whatever. That's fine. You don't have to actually work it out.
You got 9.
Mhm.
And then, so log 2 is 7.
Okay, log base 2 of 7. So we've got an answer all the way through. If we had our calculators, we could actually punch that in and get a decimal. Okay? All right, I'm giving Mackenzie a 3 this time.
Mm, 28.
28, okay. Can you use a 28?
Yeah.
All right.
Log base 2 of 26.
Okay, go ahead and put that in the basket. All right, so far so good? Seems like we can use everything. Let's try a 0.
One.
I can't use it.
Oh, she can't use a 1. All right, give that one back to me. Spit it back out. Let's try a 1.
2.
I can't use that either.
Oh, she can't use that one either. How about a -2?
-7.
-7.
I can't use that.
Nope. Peyton's being picky. All right, so why are we having this trouble?
Because I can only take numbers that are greater than 2.
And what's she spitting out?
Numbers that are less than 2. Either less than or equal to 2.
Only?
No, but
So she's spitting out what?
all real numbers.
All real numbers. So when we do this check now, it's the range of Mackenzie that has to work with the domain of Peyton. Well, Mackenzie's range is all real numbers, but Peyton can only take x's that are greater than 2. So there are numbers that Mackenzie is spitting out that won't work with Peyton's function. So now what do we do? What happens when we get a range to a domain that does not work?
Then doesn't the domain just change to mine?
Not necessarily. What does need to change to yours? It's not so much the range I put into her, it's what can only be x is greater than 2? Your domain can only be x's? Hers, yeah, her domain can only be x's. But in order to make this work, what does that mean for you?
I can only give her numbers that are larger than.
You can only give her numbers that are greater than 2. All right? So what that means is we need our h function
Have the same.
to be greater than 2. Right? We need the values that we get from our h function to only give us values greater than 2, so it's going to work with Peyton's function. Okay? This is what we call fixing it, because it doesn't just work the way it's set up, like the first two examples did. So we have to fix things. We have to make it work. And we have to make it work out here in this basket. Because once things get going, we're not allowed to fix anything on the handoff. Okay? So we set up this equation, or inequality, excuse me. Since the h function was the x cubed plus 1, and we need the answers from that to only be greater than 2, we set that inequality and we solve it. So it means x cubed is going to have to be greater than what? 1. So x's would have to be greater than?
The cube root of 1.
Cubed root of 1, which is? 1. And with cube roots, we can just take it on both sides. Take the cube root of both sides, x is going to have to be greater than 1. If it's a square root, it's a little bit more tricky. Okay, and hopefully I didn't give you any of those right now. But when it's a cube root, we can just say, okay, cube root both sides, x's are going to have to be bigger than 1, so that when I put it into the h function, I get answers that are bigger than 2. And what did you just find? You just found what the x values are supposed to be. So you just found the domain. So your domain for your q of h of x function is the result of whatever you solve here. So it's now x is greater than 0, or sorry, x is greater than 1. Just write that under that for me real quick. Okay, you guys can sit, thank you. Does that make sense? So when the handoff does not work, when the range of the inside is not going to work with what the domain for the outside is, then we have to fix it. And we have to fix it back here in the original bucket. So we have to go back and say, all right, so I need my first function, which in this case the inside was h of x. I need my first function to fit this criteria. In this case, I need it to be greater than 2. And then you set up that inequality or that equation, depending on what it is you're trying to find, and that's what you solve. And when you solve for x, that means these are the x's that work. Oh, I now know the set of x values. That's my domain. Okay? Questions? So, let's talk about this from a purely algebraic standpoint then. Because I doubt if you're all going to get together at, Lynn's coffee tonight with your little functions going, okay, you play this function and you play this function and let's put you together and see what happens, okay? So, how do you actually do it when it's on your paper for homework and you need to get to your function and your domain? So let's work with these two functions. I want v of x to be x squared plus 2. And I want r of x to be the square root of x minus 1. So we're going to do the combinations both ways. The first time we're going to talk about taking v of r of x, and the second time we're going to work on r of v of x. Okay? Now, the very first thing I would suggest you do before you even start working on the composition itself is that you state the domain and range of the functions you're being given, just like you did when you came up here. The very first thing I asked you to do was write down your function and tell us what your domain and range was. So we knew what we were working with. So even on your paper, the very first thing I suggest you do is identify your domain and range. Okay? So what is the domain for x squared plus 2 going to be? All real numbers. It's quadratic, so we can use all real numbers. How about the range? Good, because we're just taking our normal quadratic, our parabola, and moving it up 2. So y is going to be greater than or equal to 2. Okay, how about for r of x? What is my domain for r of x going to be?
X is greater than or equal to 1.
Everybody agree with that? Okay, because again, if you think in terms of transformations, we're taking the normal square root and we're moving it to the right one. So now it's going to start from 1 rather than starting from 0, and then go to the right from there. How about range? Y is greater than or equal to 0, because we don't have any k value to move it up or down, so it's still just going to go from 0. Okay, so now we know what we're working with. Let's go ahead and actually get a function here. So I want v of r of x. What's that going to look like? Any ideas?
X plus 1.
Why? How'd you get x plus 1? Whoever said it.
Because, like, x squared cancels out the square root.
Okay? So then you just end up with x minus 1 plus 2, right? So the minus 1 and the plus 2 we can combine and get plus 1. Okay? Good. All right, so what is it that we need to check? What's the handoff in this case?
Domain of r.
Careful. Which function would be first? If I had the two standing up here, which one would be first? R. Okay, so what do we have to check from R with V? Is it the domain or the range of R, if they're first? The range, what comes out of R, and what do we need to check with V? The domain, whether V can actually take that number or not. So, domain of R, range of R, domain of V. Will these numbers be acceptable in that domain? So is that range, those numbers coming out, going to be acceptable for this function to take? Yes. So if this works, and what I would usually say, and what you heard me say last year, is I would actually write this out. I want to check the range of R with the domain of V. And the range of R is y is greater than or equal to 0. The domain of V is all real numbers. Does that check out? We're saying yes. So if it checks out, then what does that mean for the domain of my new function? My x plus 1. What should my domain be? Everything worked. It's all okay. So what's the domain of my result going to be?
Y is greater than or equal to 0.
Not domain. Close.
X is
Closer.
X is all real number.
No. There's only one other thing to choose pretty much up there.
Y is greater than or equal to 2.
Oh, no, there's two other things to choose. You
X
picked
is greater
everything
than
but
equal
the
to
one that's
1.
right.
X is greater than equal to 1.
Yes. Because, remember, if the handoff works, then what do we go back to for the domain?
The starting.
The starting domain. Well, what was the starting function? R. So we go back to the domain of R if it all works. And the domain of R was x is greater than or equal to 1. Okay, so you got to check the handoff. If the handoff works, then you go back to the original domain. And that's going to be the domain of whatever your first function was. And that's the function that's on the inside. Okay, questions on that one? Let's try it the other way. What's it going to look like if I take r of v of x?
The range is easiest to the D.
I want the function first. What's the function going to look like? Then we'll do the check. The square root of x squared plus 1, like that? Agree with that? Sorry?
Just be x plus 1 is the square root, and the square cancel each other out.
So should I simplify that and just make it x plus 1?
Yeah.
No! You cannot take the square root of the individual pieces when you're adding or subtracting. You can only do it when you're multiplying or dividing. So no, you cannot take the square root of the x squared and the square root of the 1 separately. Okay, so we've got to just keep it like that. All right, so now that we have our function, what am I going to check? Because now v's the first one, right? V's on the inside, so v is going to be the first function that's going to work on whatever values we put in for x. Okay, and then v is going to hand off to r, so it's what comes out of v, whether that's going to be used as an input for r. So range of v has to work for the domain of r. So what is our range of v? What is our domain of r? Is that going to work? Yeah? So the numbers coming out of v are all going to be acceptable in r? Yeah, in this case, yes. Now sometimes it's not. Sometimes you get things like y is greater than or equal to -2, but then x can only be greater than or equal to 1. So then you have to do the fix like we talked about. But in this case it works. So what then is the domain of my new function? Which one? All real numbers, because we go back to the original domain of the first function. As long as the handoff works, then it's the domain of whatever this first function was, and the domain of v was all real numbers. Okay, so that's what it's going to look like when you're just doing the problems on paper. Make sure you actually identify the domain and the range of the functions that they give you first. Then do your composition to see what your new function is going to be, and then do the check. And if things work out, then you always go back to just that domain of whatever your first function was. On quizzes and tests, I want to see evidence that you're checking things out. If you just give me x plus 1 and just tell me that d is greater than, that the d is x is greater than or equal to 1, even though those are both correct, these are going to be 3-point problems. And if you don't have evidence showing me that you checked to make sure that that's correct, you're going to miss one of the points. Okay, so you're going to get a point for your composition, a point for having the direct domain, and a point for showing evidence that you checked it out to make sure that that was the correct domain. Okay, so practice that on your papers so that it's second nature when you get to quizzes and tests. Questions? All right, that's really all I want to get through for today.